Welcome to the DooDoo Divas Smells Like Money podcast. I'm your host, Suzan Chin-Taylor, CEO and founder of Creative Raven, the firm that helps wastewater industry contractors and manufacturers unlock the power of digital marketing, AI, and PR to boost sales and opportunities. Whether it's through our online marketing and lead generation programs or providing a fully outsourced marketing department, we are passionate about helping businesses in the wastewater and civil infrastructure sectors not just survive, but thrive in today's digital world. Each episode, I'll be bringing you expert tips and strategies to help you grow and succeed. Let's dive in. Well, hello, everybody, and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. Today, we are bringing back one of my favorite industry people and someone that I feel privileged to call a friend, Mr. Louis Titus of Titus Wastewater Solutions. And for those of you who have been tuning into the podcast for a while, the last time that Louis was on, we talked about his new innovation for wastewater treatment called the Floating Aerator. Well, a lot has happened since Louis first came onto the show with this amazing invention and innovation. And so I felt it was time for me to bring him back on the podcast to discuss what is happening now, and for what he has shared with me, all of the incredible things that they have found that this floating aerator can do, the problems that it solves, the applications. It is really, truly, from what I'm understanding, it has gone way beyond the original expectations of the problem that it was originally set up to solve. And so with that, welcome back to the show, Louis.
Hey, it's great to be here, Suzanne. It's been a little bit, so anxious to bring everybody up to speed on some of the new stuff we're doing with this thing, and it's pretty exciting what's happening out there in the real world. So we initially designed this to do a couple big things to improve oxygen transfer efficiency is always the biggest one. And when I'm speaking with engineers, that's pretty much all they think about is, what's your pounds per horsepower hour efficiency on transferring oxygen. And so once we get more into this, we've found that probably one of the more important things is the mixing efficiency, which gets overlooked by almost everyone. And so eventually lagoons get full of sludge, and it's very costly to deal with that. So sludge management now is really one of the key things that we're looking at doing. And we've had these out for a few years now. We got a lot of installations, and we've found that they actually work far better than we ever thought they would, and for a couple of reasons. They move a lot of water, for one, so that is your mixing efficiency. The oxygen transfer efficiency is the best in the industry for as far as floating aerators go. Nowhere as close to what an array of 9-inch discs in the bottom of a aeration basin at a plant is, but these are designed mostly for lagoons or big tank scum pits, things like that. And so there, the ability to move around is been just transformative as far as aeration equipment. So when I say that, most aeration equipment is fixed, whether it's bottom diffusers, they're fixed in one place, they don't move. I don't care how many of them you put in, they don't move, and they eventually get buried in sludge. And the mechanical aerators on the market now, most of them have some sort of a propeller, and they got either rotational torque or thrust, and which means that they got to be restrained with typically stainless steel cables or pipe stanchions that are embedded in a pond floor to keep them from rotating or to restrain the thrust on them. So we've eliminated all that. We have a 360 discharge, and it's an airlift pump. So it just puts it out all the way around with absolutely no thrust and no torque, which means we can tie it off with a piece of rope. And when you do that, you can let the wind blow it around. You can manually move it around. You can have different tie-up points. But the whole object is to increase the area of influence, which means that you're going to start attacking that sludge layer. And some of the things that we've found is the sludge layer is usually around 60 to 70% volatile solids. That means it can be broken down. So the name of the game in this business is to minimize the volatile solids and maximize the non-volatile solids. In other words, we're trying to reduce the sludge layer into a very small, compact, inert product, and that eventually will have to be removed. But when you do that, if you're dredging your pond every 5 years, you might go out to 10 years, you might go out to 15 years. And the other thing that it solves is your SRT, which is your solids retention. The solids need to be kept in the pond for a certain amount of time, and when that pond starts getting full of sludge, your storage capacity goes way down, and your retention time goes way down, and eventually starts short-circuiting to where you can't keep your solids in that high DO water long enough because there's just not enough capacity. So you got water in, you got water out. It takes a certain amount of time for the bacteria to work on those solids. So SRT is a very important thing in this business, and reducing the maintenance costs on sludge. Sludge is just a huge cost for, especially for small towns. It just gets unbearably. I just finished a project, or we're in the middle of a project. They spent $2 million on one pond dredging it.
Wow.
It's just insane how much it costs to not only dredge but dispose of all that.
Mm.
And so it's a two-pronged thing. So anyway, what we found is we're typically reducing those sludge deposits by about 55 to 60%, sometimes more, maybe sometimes a little less, depends on, again, on the composition of the sludge. So if you go out and do a sludge judge survey, you can kind of determine how much volatile versus non-volatile there is in your lagoons and manage it that way. So some of the other things we're trying to get rid of is odors. And what we've found, our equipment is designed to discharge subsurface.
Mm.
And when we discharge subsurface, as opposed to, say, mechanical aerators that throw water up in the air and basically it lands all the way around them, they have a tendency for all the high DO water to be on the surface. They're not very good at driving that DO down to the bottom of the lagoon. So if you got a lagoon that's 12 foot deep, but all your DO's in the top 2 feet, 3 feet, 4 feet, you're not getting full treatment. You're not getting you're not getting treatment at the bottom of the lagoon. So
Right.
uh,
Well, speaking from, because one of the technical things that I thought was interesting, when I came up there to tour the plant with you, is that it comes in different sizes. And
yes.
and I'd like you to kind of explain that for those of you who are trying to think of a visual on how does this thing really work. I think an easy one is think of a Roomba for your house. Imagine having a really big Roomba for your lagoon, and it's moving around and it's doing its thing. But when somebody is specifying one of these units, tell us a little bit about the different configurations, because you did run into one that I recall where you couldn't have, I don't know if it was the side output where it had to be horizontal versus the vertical stack. So maybe if you can explain to the audience that it comes in the different sizes and in those different applications and why you would want to choose one over the other.
Oh, that's very, very good question. And versatility is a big deal. We make these now in 4 sizes.
Oh, wow. Okay.
And yeah, we just added a shorter version where we're finding there's a lot of lagoons that are only 5 feet deep.
Okay.
And a 5 foot deep lagoon wasn't deep enough for my smallest unit. So we measure the size of these from the water line. And keep in mind, people, that there's a very large uh, float that's filled with dock foam that suspends the unit. Most of the unit is actually suspended down into the water, and it's actually weighted with a concrete ring that's about 2,500 pounds that helps stabilize it, and it also pulls the head subsurface So therefore, we get the subsurface discharge that we're looking for. We measure the size of these from that water line to the center of our diffuser. So, and again, I like to explain a little bit of how this thing works. We have a membrane diffuser, very similar to what they have at wastewater treatment plants. Only ours is much larger, and we're the first one to take a membrane diffuser. And instead of sitting it on the floor of the lagoon or the tank or whatever it's in, where it quickly gets buried, we actually put it in a floating housing that moves around, again, moves around the lagoon. That's an airlift pump. So as it releases air, the air goes up through the structure and it's pushing huge amounts of water, huge amounts of water. These things move a lot of water and it hits a specially designed head and it discharges out horizontally at a 15-degree angle down. And what that does is it gets us very even distribution of the high DO water. I can't push air bubbles down into water. A lot of people try to do that, but you can push high DO in. So as we're transferring oxygen up through the machine, the water that's high in DO gets pushed out at 15 degrees downward and out towards the bank, and it's pulled in. And this is the point you were referring to. We can pull it in either straight up from the bottom with a bottom intake, or we can put horizontal intakes in and pull that water in horizontal. And the purpose for doing that against versatility, especially in big facultative lagoons you've had a facultative lagoon that's been in service for years. They're usually very, very large, uh, giant surface area, and they don't really want to disturb their sludge. And usually their sludge isn't that deep. It's usually under a foot deep. And so they want to continue breaking that down anaerobically, which it will, because it's an anaerobic layer down at the bottom of the pond. They want to aerate all the water over the top of that, and again get the DO down to the bottom, so the bacteria are actually working on the sludge layer from the top down. So if your water is stratified and all your DO's up towards in the top 2 or 3 feet, well, if you put a DO probe in your lagoon as you drop down to that sludge layer, it goes to pretty much zero. And so being able to pull the dead water off the bottom and aerate it and then push it back down with a horizontal intake, we don't have to disturb that sludge layer. We simply mix all that high DO water above the sludge layer. Now, smaller ponds, most people wanted to literally pull all that sludge up and suspend it and try to break it down as much as we can. And we can do that on smaller ponds. Bigger ones, it's much more of a problem. So either way you do it, we make again, we measure from the water line down to the center of our diffuser, which is a cone. It's a thrust conical diffuser. It's very large. It has about 40,000 perforations. And we measure from the water line down to the center of that diffuser, and we have a 3 foot, a 4 foot, a 6 foot, and our big one is an 8 foot model, so it's 8 foot down.
Wow.
And obviously, the deeper you push that diffuser, the longer the bubble has it to contact the water. We call these twisters because we actually get a cyclonic action as that bubble goes up through it, which keeps the bubble in the water longer. This is a game of keeping a bubble in contact with the water as long as you can to dissolve as much oxygen into that water column as you can. And you also want as fine a bubble as you can get.
Right.
So with our system, with a perforated membrane, we get a very fine bubble. Fine bubbles actually are better at moving water, so it's actually a better mixer. And it's very much better at dissolving oxygen into that water column. And so therefore we get high DO levels right from the bottom right to the top. If you want to just disrupt that sludge layer, we can. If you want to leave it intact, we put side intakes in. Sometimes if we're putting these in EQ basins, which EQ basins is an excellent application for this, we can actually put both side and bottom intakes in. So the machine can completely set down on the bottom and function until it runs out of water, basically. And when I say function, this machine has no propellers. It has no moving parts. It has no electrical power in the water. It's strictly air driven. And the big deal, and this is a big safety deal, and if there's safety people out there, one of the most dangerous things your crews do is have to go out and work on mechanical aerators in a wastewater lagoon. It's dangerous. You're in a very unhealthy environment, and we get rid of all those issues. No more boat access maintenance. The only time we go out there in a boat is to unhook the crane after we set it in the water. And it has about a 10-year service life before the membrane has to be replaced. And again, you still don't have to do that in the water. The machine is pulled out of the water with a crane. You pressure wash it, you disassemble it, and you install a new diffuser. It takes about 4 hours. That's every 10 years.
Wow.
And so it's a pretty incredible machine. And uh, we think it's really going to disrupt the industry. Some of the other big bonuses to this, we live in Wyoming. It's very cold here in the winter. My first installation here in Wyoming was in Riverton, Wyoming. We put 2 units in. It was 8 degrees out when we put them in. I had to break 12 inches of solid ice to put them in. We got them up and running, and the next week the temperature dropped to 44 below zero. And in Riverton, Wyoming that year, it stayed at 0 to 40 below zero for 3 months. 3 months. There's not a lot of aerators that will do that outside of bottom diffusers. And but we dramatically increased the efficiency of bottom diffusers again by moving around and eliminating that getting buried in sludge.
I'm
And
glad
another thing
you
with
brought
bottom
that,
diffusers,
I'm glad you brought that topic up about cold weather, because I
yeah,
remember you saying that there's many choices out there, but when they're specified by the engineer, they're looking at the power, like you're saying, the geo and the horsepower, but they're not considering the environment or the climatic changes that may happen that are going to affect that equipment. And for those that aren't aware, Lewis, I'd like you to explain what things will not work in a frozen environment.
well, probably the worst one is when you throw water up in the air, which, a common aeration system is a mechanical aerator. It's a big electric motor. It sits on pontoons, and basically it's got a propeller and it throws water up in the air. Well, when it's 20 degrees below zero, that's not a great practice. And most instances, they just have to shut them down, and they have no treatment in cold weather. You really shouldn't see any of those above the Mason-Dixon line, but you
Mm.
do. I'm amazed since I moved here how many municipalities in Wyoming, Montana, Iowa, all these cold states are running mechanical aerators, and they have to shut them off in the winter. And so we've eliminated that issue. We're better at mixing. We've eliminated the extensive cable and restraining systems. We've eliminated the power in the water. We've eliminated the boat access maintenance. There's nothing to grease. There's no propellers to crack and wear out. Uh, so again, it's every 10 years we're going to do maintenance on this thing.
Which is that's absolutely amazing. So for those of you who are tuning into the video version of this podcast, what you're going to be seeing on the screen is a short clip from a recent project, so you can kind of get a feel for what this product looks like in a lagoon, and its scope and its scale and the bubbles that it's producing. So it's pretty amazing. And this project was at, I hope I get this name right, Lewis, if I don't, correct me. It's Sunnyside in the state of Washington. Very large lagoon. They put in multiple units of this. So while this is running, and then we'll just let it play, and why don't you tell us a little bit about this particular project? Because I think it's really fascinating in the logistics of this, in that it is a municipal facility, but yet most of his waste stream is coming from an industrial plant. And it's all animal waste. It's heavy fog, high concentration. So this is kind of a tough job. I think it's like a tough project. It's a lagoon that's being asked to do a lot of heavy lifting because of what's coming into it. So tell us a little bit about that project and just,
Well,
problem solution and what they're doing now with these aerators.
This is it's an industrial municipal treatment plant.
Right.
So it's run by the city of Sunnyside, and they have three basic customers. But the main one is a dairy processing plant, and it's a very large dairy processing plant, which means all the wastewater coming from this plant is animal waste. It's all fats. And so we're doing a couple things there. We're now pre-treating it with our small twister. We make two versions. We make one for sewage pump stations that specialize in getting rid of fog. We've actually installed one of these to pre-treat that wastewater coming out of the dairy facility to break down that fat and before it
Okay.
goes out into the lagoons. Uh, the original design had 20 high-speed surface aerators. Again, they're throwing water up in the air. A lot of maintenance on them, all boat access maintenance, uh, and very poor mixing. It's a very large lagoon, and it was 10 feet deep and literally had 10 feet of sludge in it. The sludge was clear to the surface of the pond. So this is where they spent a couple $1 million dredging this pond. We just completed phase one of this. We put 10 of our aerators in, and they're pouring the concrete slabs now to put 10 more in. And this has all been sized uh, by parametrics, so it's all based on the loading. Typically, when you get in these industrial discharges, the loading is way higher than it is in a municipal. So your CBOD is
Right.
extremely high, so it takes a lot more oxygen. And so anyway, we're in the middle of this project right now, and we got a successful launch of our first 10 units, and they're getting set up now to put 10 more in and in the main pond. And we're also going to start replacing some high-speed surface aerators in what we call cell one, which right now still has some surface aerators in it. Ours are in cell two. So the object is to, again, to break down these animal fats. All this wastewater is when it leaves this lagoon is going into an MBR plant. And pretty much everybody in the industry knows that membrane plants do not like fats, oils, and greases. And this plant is all animal fat, which is very difficult to break down. So again, pre-treating it with ozone, we use ozone to break those fats down, and then we give them aeration and mixing in the lagoons with our aerators. When they had the high speeds in, they had to shut them off 3 months out of the year. So they only got 9 months of treatment, which is one of the reasons their ponds were full. We don't have that problem. It'll run 365 days a year. And they can run them off DO controls. They can, there's a lot of things they can do to regulate the DO levels in this pond. But initially, what we found is our DO levels were the same. Didn't matter where we measured it, top, bottom, one end of the lagoon to the other. Very consistent DO readings. So a very interesting project.
And it just goes to prove we are in very exciting times with a product like this coming out in the market that in every installation so far, since the first time we brought you on the show, it's just been one success story after another that this is truly going to be a game changer for anybody that's doing wastewater treatment with a lagoon, but not just on the municipal side, as you're seeing with some of this. I see this is going to have huge impact for any type of industrial pretreatment where lagoons are being used for that as well. So I'm going to be really anxious to see how this is all going to develop even further. I anticipate there's going to be even more and more applications for this product. And to think, it kind of really was born from your initial flagship product, which was the Titus Twister for odor abatement, dealing with rags, dealing with fog in pump stations, and just taking that concept of, wow, it does this in a wet well. I can just see Lewis's, wheels turning, going, I wonder what that could do in a lagoon. So, my hat's off to you in coming up with this. And just, I imagine the surprises you get from this are very, very rewarding in
Oh
just
yeah.
that it's doing so much more than you ever could have possibly imagined in solving more than just one problem that you went after to solve. And so congratulations on that. And so anybody out there that wants to know more information about this, I invite you to go visit their website. It is Titus WWS. So that's TITUS WWS.com. More information is there. They have a YouTube channel. There's going to be more information in the show notes below. You can get a hold of Lewis on LinkedIn or on the phone number below, and I'm sure he will be more than willing to assess how the Titus Floating Aerator may be able to help you with some of your toughest wastewater challenges. So again, Lewis, thank you for coming on to the show.
Could I make a couple real short points here, Suzanne?
Sure.
You brought up rags. Rags are a big issue in the industry, and this thing goes through rags like they're not even there. You can't rag it up. So we solved the rag problem with mechanical mixers have a big problem with. One of the other things that we're now looking at using it for is even in treatment plants in mixed liquor basins with the arrays of bottom diffusers, and there's lots of them out there. And one of the problems they got is, again, every couple of years they got to transfer the water to another tank, and they got to go in and clean all those. So we've been doing some testing, and we think that we can reduce those maintenance frequencies by putting our floating aerator in and cleaning that sludge off of your 9-inch discs, keeping it moving around your. Yeah. So even in mechanical plants, they have an application. Scum pits is another one. These things are running very thick sludge. So it doesn't matter how thick the sludge is, we drop them in and they run. And again, there's no moving parts to wear out. So a lot of new stuff out there that we're looking at doing that we think is going to change the whole industry.
Wow. Well, thank you for reminding me of that and bringing that up. So that just opens the door for more of you who are listening that are beyond Lagoon to explore what this could do for you. So again,
not just for lagoons anymore.
Not just for
even we have a couple large pump station projects that we're looking at because it's big, and so when you got a 50 MGD pump station, our little twister just doesn't have enough oats for that. We can now use our floating aerators for that.
Wow.
Lots of new applications.
Yep. So sky's the limit there, Lewis.
Sky's the limit. Yes.
Sky's the limit. Well, again, thank you for coming on to the show. For those of you who listen, I hope you got something out of this, and we'll reach out to Lewis and explore the possibilities. I really encourage you to do so because I've seen it in action, and it is a really amazing piece of technology. As they say it in Britain, ooh, it's got a go back. It does. So thanks for tuning in. And until next time, keep it flowing. Thanks for tuning in to today's episode. If you're ready to take your marketing to the next level and start increasing sales and opportunities for your business, reach out to us at Creative Raven. We're here to help you thrive in the digital landscape. Visit creativeraven.com or click the link in the show notes below to schedule a call and learn how we can support your growth. If you enjoyed the insights on today's episode, be sure to hit subscribe so you'll never miss an update. Until next time, keep growing and keep it flowing.